All right, so let's begin lecture 6. We're talking today about exponentials and logarithms. And these are the last functions that I need to introduce, the last standard functions that we need to connect with calculus that you've learned about, and they're certainly as fundamental, if not more so, than trigonometric functions. So first of all, we'll start out with a number a, which is positive, which is usually called a base. And then we have these properties that a to the power 0 is 1. That's how we get started. And a to the power 1 is a. And of course, a squared, not surprisingly, is a times a, etc. And the general rule is that a to the x1 plus x2 is a to the x1 times a to the x2. So this is the basic rule of exponents. And with these two initial properties, that defines the exponential property, the exponential function. And then there's an additional property which is deduced from these, which is the composition of exponential functions, which is that if you take a to the x1 power to the x2 power, then that turns out to be a to the x1 times x2. So that's an additional property that we'll take for granted, which you learned in high school. Now, in order to understand what all the values of a to the x are, we need to first remember that if you're taking a rational power, that is the ratio of two integers power of a, that's going to be a to the m, and then we're going to have to take the nth root of that. So that's a definition. And then when you're defining a to the x, so a to the x is defined for all x by filling in. So I'm going to use that expression in quotation marks, filling in by continuity. This is really what your calculator does when it gives you a to the power x, because you can't even punch in the square root of x. It doesn't really exist on your calculator. There's some decimal expansion. So it takes a decimal expansion to a certain length and spits out a number which is pretty close to the correct answer. But indeed, in theory, there's an a to the power square root of 2, even though the square root of 2 is irrational, and a to the pi, and so forth. All right, so that's the exponential function. And let's draw a picture of one. So we'll try, say, y is equal to 2 to the x here. And I'm not going to draw such a careful graph, but let's just plot the most important point, which is the point 0, 1. That's 2 to the 0, which is 1. And then maybe we'll go back up here to minus 1 here. And 2 to the minus 1 is this point here. This is minus 1 1/2, the reciprocal. And over here we have 1. And so that goes all the way up to 2. And then exponentials are remarkably fast, so it's off the board. What happens next? Out at 2, it's already above my range here, but the graph looks something like this. All right? Now I've just visually, at least, and graphically filled in all the rest of the points. So you have to imagine all these rational numbers and so forth. So this point here would have been 1, 2, and so forth.